Hello friends, in this video I will explain the concepts of current and voltage. Anyone who learns electrical and electronics constantly uses these concepts but has difficulty in understanding. An electrical circuit basically contains a power source and a load. The load is a lamp here. We have a cable carrying the current that will make this lamp turn on. We define the current as the amount of load per unit time. So what does this mean? Let's see together. First of all, according to the Coulomb law, everyone knows that opposite charges attract each other and the same charges repel each other. To understand how electric current is formed, we need to know the atom's electron configuration. Our cables carrying the current in the circuit are conductive cables. What is conductor then? Atoms with 1, 2 or 3 electrons in their valence orbit are conductive. Here you can see the electron configuration of the copper conductor. It has a total of 29 electrons. There is 1 electron in its valence orbit. It is easy to give this electron because it has 1 electron in its valence orbit. Therefore, by giving this electron, an electric current is created. For example, gold and silver have 1 electron in their valence orbit and are very good conductors. But since copper is available more in nature, the cables are made of copper in electrical circuits. So, what is a non-conductor? A non-conductor, on the other hand, has atoms with 5, 6 or 7 electrons in its valence orbit. It is difficult for insulators to transfer these electrons because there are too many electrons in their valence orbit. As they cannot transfer electron, they don't transmit electricity. So, how is the electric current created then? 1, 2 or 3 electrons in the valence orbit of each atom of the conductor are carried in this way by flowing to the valence orbit of the other atom. This creates the electric current. The power source in the electric circuit provides potential difference, that is voltage, providing the movement of electrons. The number of electrons in the negative pole of the power supply is high. In the positive pole, the number of electrons is low. Plus charges on the positive pole attract electrons on the negative pole. Electrons in the negative pole reach the plus pole by moving electrons in the valence orbit of the conductor. In this way, electric current is created. The lamp illuminates when electrons are moved from the negative pole of the power supply to the positive pole. The more the number of electrons in the negative pole, the higher voltage value of this power source. For example, while the number of electrons in the 1.5 volt battery that we use in daily life is low, the number of electrons in the negative pole is higher in the 9 volt battery. In this way, larger currents with larger potential differences can be created. Thanks to the movement of electrons flowing through the conductor, an electric current occurs. So, how is the intensity of this current determined? If 6.25 times 10 to the power of 18 electrons flow through a conductor in 1 second, this creates 1 ampere. The flowage of so many electrons per second from a cross-section of the conductor created 1 ampere. If 1.25 times 10 to the power of 19 electrons flow through the conductor's cross-section in 1 second, this creates 2 amperes. When the number of electrons flowing in a second doubled, the current intensity flowing through the conductor also doubled. We can compare the motion of these electrons flowing through a conductor to water flowing through a pipe. The water here is the electrons that flow through a conductor in electrical circuit. The direction of movement of electrons in the circuit is always from the negative pole of the source to the positive pole. But the direction of current is considered from the positive pole of the source to the negative pole. When solving the problems, the current direction is always taken as reference and the process is performed accordingly. At the beginning of this video, we explained the current intensity as the amount of charge per unit time. We can show this as a formula like this. Here, the unit of current intensity is ampere, the unit of charge is coulomb, and the unit of time is seconds. If 1 coulomb charge is in a second, namely 6.25 times 10 to the power of 18 electrons flow in 1 second, this generates 1 ampere. If 2 coulomb charge in 1 second, namely 1.25 times 10 to the power of 19 electrons flows in 1 second, this creates 2 amperes. This is how we can explain the current and the relationship between the current and voltage. I hope it was useful for you and you enjoyed it. Hope to see you in our next lesson. Goodbye.